To enable impossible measurement with our sensor that can be integrated in any kind of physical object, from a bearing to a tire, even implantable medical device.
Hi, I'm Dave Wilson, and we're here at the 2026 Dewesoft Measurement Conference. We are here with the winners of the Engineering Excellence Award. They're from RadioSense, and a real exciting and interesting application to talk to you about. So tell us a little bit about who you are, introduce yourself if you will, and then a little bit about what RadioSense does.
Okay, so I am Sara Mendola. I am the CEO of RadioSense, which is an engineering company based in Italy, in Rome. The company specializes in developing innovative, battery-free wireless sensor for many diverse and creative applications, and you will see an example in a few seconds.
That's exciting. So the battery-free wireless, and those are words that just popped out. I think they're the first words in the name of the title. In fact, let me just read the title so people know. Your paper was called Wireless Battery-Free Measurement of a Bearing Temperature of High-Performance Powertrains, right?
Correct. Yeah.
And so the wireless battery-free, I just want to make sure we get in there because it's so essential to what you did.
Yeah, we would like to enable impossible measurement with our sensor that can be integrated in any kind of physical object, from a bearing to a tire, a package, and even implantable medical device.
Your marketing people are going to love that. Enabling impossible measurements. That's awesome.
Whenever it's hard to put a wire or complex electronic or battery or very severe or harsh component, we can design sensor to enable to generate those information.
Wow, lovely.
My name is Carolina Miozzi. I work as a system engineer and I'm partner of RadioSense. I work in RadioSense since 2019. My background is biomedical engineer, to be honest.
Yes.
But now I'm pretty much responsible of almost all projects that concern sensorization of small metal components with battery-free wireless sensors. So
she was leading that project.
Yes, I did the project with that we will present right now.
Awesome, and I'm sure biomedical engineering, that background has got to really be a great background for this, because a lot of the stuff you have to sense non-invasively.
Exactly.
And so
correct.
that's got to be a really great foundation, right?
We are both medical engineers.
That's awesome. Well, this is great. This application is just fascinating. So getting to this enabling the impossible measurement, tell us a little bit about what was the problem here and what was hard to get to and what was hard to measure. Tell us about that.
A very, key example of our way of working, because customers usually approach us with some challenges.
Sure.
In that case, we have been approached by the F1 racing team from Ferrari. They were looking for some technological solution to measure the temperature of a key crucial component that is a bearing that is integrated within their power unit. And there was no way when we met this team to get this information out of that power unit. And some hidden component in that application can really be a game changer. And they were aware that monitoring the health status of that bearing could really, let's say, save the game or save the race and make the difference on a track.
Awesome. So inside these powertrains, they're the hybrid powertrains, right? There's some pretty big dynamic forces going on inside there, so it's a pretty tough environment. And then you mentioned F1 and Ferrari. Those are extreme.
Exactly.
Right? So getting in there and measuring that was a real challenge.
Yeah.
Extreme rotation, severe electromagnetic interference, tight geometries.
Why couldn't you just put a thermocouple on it and measure it?
Yes, thermocouple, because it rotates, the bearing rotates. It cannot be.
Okay, right. So this thing is spinning.
Yes.
So you just can't go and stick an RTD on it or a thermocouple.
Yes.
You have to measure it while it's spinning.
Yes, correct.
I see.
So that wireless communication we must use wireless communication because wired sensors cannot access the right measurement on the bearing. Because to really predict anomalies, we have to measure the temperature on the bearing. Otherwise, with wired sensors, we can access the structure around the bearing, but there is temporal filter data and also, we are measuring the temperature of the structure, not of the bearing.
Right, and the structure's big. It's got thermal mass, and it's distributing,
Exactly.
and if anything is fluctuating fast, that would all be filtered out by the structure.
And here the goal was to early predict some anomaly before the failure.
So you want to, so now we're getting to the challenge. It's spinning. You need to measure thermal anomalies on this and not the structure in order to predict failure before it happens.
Exactly.
Ah, okay, fantastic. So you did it, and you put the sensor where? And do you happen to have one here today?
We put the sensor on the bearing.
On the bearing.
On the bearing. We can say that we have transformed the bearing into a data generator into a sensor. So the bearing itself became a sensor, and it is. We decided for this specific application
so it
to.
goes like this, right?
It's like yes, like this. Probably it's better. So this is a wireless, but also battery-free sensor, and it receives the energy from an electromagnetic field generated by an interrogation antenna that is positioned on a fixed position on the motor, electric motor, and. So we guarantee the link with a capacitive coupling between these two components. So the coupling is electric field driven, so not driven by inductive coupling, magnetic field.
Like my toothbrush is different, right? Okay.
Yeah, it is.
Yes. But the electric field is the enabler of the coupling.
So you take this as the antenna. You generate an electric field that
Correct.
couples to this spinning
Yes.
bearing over here,
Correct.
energizing that. And that energy is harvested and brought to a chip.
Yes,
Exactly.
to supply the chip, to measure the
And then
temperature.
the chip wakes up.
It wakes up, correct.
And then what happens?
And then what happens? It measures the temperature.
Measures the temperature.
And it
What's the resolution of that?
resolution is 0.5 degrees.
Over a pretty good range, I understand, right? I mean, from into the hundreds of degrees Celsius down below zero at
Yes.
0.5 degree resolution.
Yes.
Incredible.
Sorry, accuracy, not resolution.
Accuracy. Oh, you see? I knew that. I was just testing you.
Okay.
Resolution is much better.
Resolution is much better. Accuracy, sorry.
the
Accuracy
resolution's
0.5.
It's 0.1.
Wow.
Resolution is much lower.
Well, I'm glad we had this discussion. So 0.1
Yeah.
Yes, correct.
resolution. Incredible. Okay, so it wakes up, it takes the measurement, and now it's got to get back.
Yes, we have to get back. So it modulates the signal received from the interrogation antenna with the information about the temperature data in real time.
Wow. Now there's a word I've just been dying to say, and it was called backscattering. What does that mean? What's going on here?
Backscattering,
Yeah.
exactly. This is what it means that so you receive the signal and it modulates this signal with the information that come back to the interrogation antenna, and then it is
So now it backscatters, modulates it, backscatters it through the antenna, the same antenna that sent it, and it comes through this cool little cable right here
Little cable.
over to the RFID reader. Is that correct?
Yeah, correct.
Where what happens in there? It turns it into the data that gets sent.
Yes. Then, from the reader unit,
Yeah.
we decided to use an architecture that is easy to be integrated into the test and measurement world. So we decided to develop not only the software to enable the interrogation and the communication between these two components, but also to bridge the gap with the test and measurement and this kind of wireless technologies by developing an openDAQ bridge.
Yes.
So that we are seamless integrated with the Dewesoft ecosystem, Dewesoft X, Dewesoft Mobile.
I think that was one of the first example of integration of third parties hardware component, that in that case is our RAIN reader, within the Dewesoft ecosystem, thanks to the openDAQ platform.
Yeah. So look, this is cool. I mean, all of that is genius. I just might. So let's just start with that. That's incredible. But then you turn that data into a measurement stream that was through openDAQ, that was compatible with all other measurement streams, like your structural measurements and your electrical measurements.
Correct.
And I assume time synchronized into this.
Correct.
So now you get the thermal profiles, time synchronized with any other profiles that you may need to correlate to.
Exactly.
And that shows up downline into Dewesoft X, right?
So it will really improve the integration with multiphysics approach. So we can combine signals coming from different data sources and sensor within the same environment. And this will be really a big step toward our mission. We say that we have been collaborating with Dewesoft for many years. We aim to bring our sixth electromagnetic sense in the wireless, in the testing and measurement world. So before openDAQ, we were able to send data towards Dewesoft, but we were struggling in controlling external devices. So now within the same framework, we can both configure the reader device that is receiving those data and visualizing and processing in real time the thermal profile.
So this is impressive. So with openDAQ, then your sensor now becomes a candidate to be just like all other types of sensors as far as here's the data, and it can live in this ecosystem and be used for correlation and analysis and modeling and what have you. So it just completes the journey for the signal.
Complete the journey.
Wow, that's fantastic. So what did you discover? What came out of this? And what do we now know based on these readings?
We did a lot of tests on bench. We demonstrate that we were able to early detect some failure. So we collect some kind of thermal signature from different components, and we clearly see that was some anomalous trend that was correlated to some component that was not working properly, that was a damaged bearing.
Wow.
And we did some tests with a wireless sensor embedded on the bearing, wired PT1000, and also infrared sensor.
Yes.
So comparing each other, and we discovered that our sensor, our technology can really predict the temperature anomalies, the anomalies through the temperature profiles. Instead, the wear sensor is almost flat, so cannot achieve this information.
And so the IR sensor, you said the PT1000 sensor, right?
Yes.
That was great, except that had to be in an open system that was partially disassembled in order to make that measurement.
To make the infrared.
But yours is in the enclosed system, right? You're in the enclosed system. It's sealed. It's at performance. It's experiencing all those conditions.
Yes.
And giving you the signal that you need to do the early prediction of possible failure.
And in theory, it could be also integrated in vehicle, because
well, that excited me. I mean, it's like, well, my car could be better now because of this. That's
because
fantastic.
Now we are on the test bench, but we could integrate all this system directly in vehicle by integrating all the electronics with the electronics of the car.
Sure. So Ferrari has the opportunity now to take this information, improve their systems.
Exactly.
And hopefully the cars we drive now can also be improved, as a result as well.
And this is a key feature of the technology, because since the sensors are battery-free, non-invasive, they can be really embedded into the component, so we can track the component throughout its life cycle, from the early stage of the design of the component, running many tests on the bench, and eventually also keep monitoring while it is in exercise up to the end of life with the same sensor. You don't need to take care of maintenance or replacing the battery.
This is incredible. So you're saying we can track this bearing design, and we can see how it performs over time, and then try maybe a different bearing design and how that performs over time, and eventually create better components that stand up to these conditions.
Yes, engineers sometimes lack this information because they can monitor somehow till the validation test or phase, and then what happened to the component in the real life condition when it is inside the vehicle.
That's
also to
fantastic.
Provide this information back to the developing and testing chain.
Well, I have to tell you, it's. I looked at it, I said, it's genius.
Thank you.
This is truly amazing, and I see that you're taking the sixth sense.
The sixth sense.
And your marketing guys must be thrilled with these statements, but I get it. You're taking this new knowledge in a new dimension of information and then being able to integrate it in with all the old dimensions and coming up with better ways to understand these systems because of how you've innovated on these things. And I know you guys are really innovating in all these different areas, and there's probably a lot more to talk about in the future. But I think we'll leave it at that. And I just want to say congratulations for winning the Engineering Excellence Award, the very first award. And you're the first top winner, and you always will be. You always will be. So,
we're very honored.
No, it's really great. And maybe we can just leave it with a word of advice for future people who are doing this kind of work. What would you say to people to inspire them to innovate and be creative and create the amazing results out of innovative approaches?
Good question.
Thank you.
I think that to get challenge and try to study and try to face even not easy challenge applications could be solved some way, and to use some the brain to try solving new application, because innovations is everywhere, and I think there are a lot of innovation everywhere, but we can do much more, even more than this.
So well said. All the experiences you have.
There's always the possibility to do something very interesting, and it's awesome to work in a company that where I can do this for work. It's a privilege.
Wonderful. Well, we really congratulate you, and thank you for sharing this incredible innovation and this inspirational story. And I know you guys are going to do great things in the future too, so we're looking forward to seeing all that. So thank you, and we'll see you later.